Hello everyone, I am Sravan Kumar Kurapati and today I am presenting ContextWeaver, an advanced multi-document reasoning engine which was developed for the final project. ContextWeaver goes beyond traditional RAG systems to perform true multi-document reasoning with uncertainty quantification, automated fact-checking, and hybrid retrieval. The project achieved 12 out of 12 tests pass with a 100% success rate and exceeded requirements by implementing three core components instead of two, plus four major innovations. Let me show you how it was made. So, moving on to the next slide. Traditional RAG systems have critical limitations. First, they only retrieve documents, they don't reason them. Second, they fail completely when queries are outside their knowledge base. Third, they cannot detect contradiction in the information. Fourth, they provide no confidence metrics. And finally, there is no fact checking aspect. Contest Weaver solves all these problems. It performs multi hop reasoning, chaining information across multiple documents through 2 to 3 reasoning steps, achieving 85% confidence, which is 2.3 times better than baseline systems. It uses a three-tier hybrid retrieval system, trying local knowledge base first, then falling back to web search, and finally to LLM knowledge. This ensures that 100% query coverage is done, no question is left unanswered. It automatically detects contradiction with 95% confidence and explains why they exist. It quantifies uncertainty using Bayesian estimation and fact checks every answer against source document. Now let me show you the system in action. I will show you a live demo. Basically, I use Streamlit. So I already started my Streamlit application. You can see my UI here, which is hosted on the local host 8501 port. The system is built on Streamlit, as I mentioned before. The system initializes 11 modules. So let me click on initialize context weaver. You can see the progress bar loading each component like document processor, vector store, reasoning engine, all the way through fact checking. So once the system is ready, it will let us know by a celebration message. Now let me enter a query to check how it actually works. So one of my query is like, is moderate coffee consumption safe for heart health? So let me analyze with context weaver. You can see the live pipeline execution here. So it will go step by step through all the process. So in stage 1 the query will be validated. In stage 2 it searches the local knowledge database. If it found some document which are relevant, it will fetch the data from local data source, or else it will search on web. So currently that process is ongoing and the rest are followed now. The third stage is like multi-factor ranking, like combining similarity, credibility, recency, and quality scores. Fourth is multi-hop reasoning, performing reasoning across documents. And fifth one is contradiction detection, like if at all there are any contradictions, they will be listed here. And if there is uncertainty calculating using Bayesian confidence, it will be detected in the sixth stage, and fact checking will be done in the seventh stage. So we can look at the results. So basically documents have been retrieved locally. So a local knowledge database was created. So these are the files that I created manually at my end. so which have been used to answer this question. And in this case, the generated answer is like yes, moderate consumption of coffee is considered safe for heart health and may even have protective cardiovascular effects. So it also got the study related details and it also got the research related details. So how did the analysis and how is the uncertainty factor and what is the fact check that was done and the contradictions that are done can be seen over here. So all the details have been listed out here. Moving on, I will show you another demo where the data is not available in my local file system. So for example, I will just ask like is chicken healthy, for example. So I will try to analyze with ContextWeaver again. It will go through the same pipeline as I mentioned before. First it will search the local knowledge, and if it is not available it will automatically fall back to the web search. The system is usually reaching out to the web search now as those files are not available. So let's wait for this process to complete. Basically I used open API for my calls, so that can be seen over here. So for the source, it has indicated that it has got the details from web. So fallback method has been used and the confidence is 75%, and which sources from web has been used has been listed here. So we can go to those resources and see the information, and it has generated the answer. So as chicken is considered healthy when consumed as part of a balanced diet, and it came with the reasoning as well. So these are the analytic metrics. So multi-hop was not used in this case. Uncertainty has been checked, and as well as the fact checked was not activated because it was actually retrieved from the actual information in this case. So these are the live demo steps of two scenarios. So moving on with the presentation. Let me explain the core components. The project required implementing at least two components, but I implemented three. So I achieved like 150% of the requirement. Component one is the RAG system. This includes hierarchical knowledge base organization, Chroma DB vector storage with 1536 dimensional embeddings, four different chunking strategies, where hybrid performed best with 77.6% similarity, and a multi-factor ranking system that combines five factors instead of just similarity alone. And the second component is prompt engineering. I created like eight specialized prompt templates for different type of reasoning tasks, implementing the context management with 8,000 token budget, designed five user interaction flows, and handle six edge cases like when there are no documents or when queries are out of scope. And the third component is synthetic data generation. The system generates question answer pairs with three difficulty levels, implements data augmentation, and achieved 94.4% quality score and 81.9% diversity score, both exceeding the required thresholds. It also includes ethical safeguards like PII detection and bias monitoring. Beyond these three components, I added four major innovations. First, hybrid retrieval with a three-tier fallback. This allows the system to handle any query. Second, multi-hop by reasoning for connecting information across documents. Third, Bayesian uncertainty quantification for transparent confidence scoring. And fourth, automated fact checking that verifies every claim against sources. So this is the whole architecture overview. ContextWeaver uses 8-stage sequential pipeline. It starts with query validation as shown in the demo, then hybrid retrieval when it intelligently chooses between local knowledge base and web search or LLM based direct knowledge, then multi-factor ranking applies 5 weighted factors, not just for similarity. Graph expansion uses network X to find related documents through the knowledge graph. Multi hop reasoning performs up to three reasoning steps, building logical chains across documents. Contradiction detection identifies conflicts and explains them. Uncertainty quantification calculates like the Bayesian confidence with component breakdown. Fact checking verifies all claims. And finally, like response synthesis generates the answer with citations and all metrics. The technology stack includes OpenAI GPT 4 Turbo for reasoning, ChromaDB for vector storage, LangChain as the framework, NetworkX for knowledge graphs, and Streamlit for the interface. The entire system is 11 modules and 5,000 odd lines of production code. And coming to the performance statics, let's look at the verified performance metrics from the comprehensive test suite that we executed on December 12th. All 12 tests have been passed. That's 100% success rate. Multi-hop reasoning achieved like 85% confidence, and contradiction detection at 85%, and contradiction detection at 95%, fact checking at 100%, synthetic data quality at 94%, which is outstanding. And for synthetic diversity, it was 81%. Similarity search was around 77%, and full pipeline time was around 27 seconds. Now here's why it's really impressive. The comparison with baseline RAG systems, multi-hop question strategy answers was more accurate. Baseline is like 34%, and ContextWeaver achieves 85%. That's like a 150% improvement. And the contradiction detection here, like baseline was 12%, ContextWeaver was 95%, so 692% improvement. And out of domain coverage, like baseline is 0, ContextWeaver is 100%, so it is infinite improvement as it doesn't exist today. During my implementation, I faced some challenges. The first challenge was related to the tick token compilation failing because it needed a Rust compiler, and I resolved this by installing Rust via homebrew. And a critical design challenge was choosing between fine tuning and synthetic data generation. Fine tuning would take at least 20 to 30 hours. I strategically chose synthetic data, which took around 3 to 4 hours, and used the save time to implement four major innovations. This gave me three components plus four innovations, much more impactful than two components with fine tuning. The third challenge was like the integration challenge, was getting the work across 11 modules to work together seamlessly. I solved this modular architecture and comprehensive testing, achieving 100% test pass rate. So these are the some of the lessons that I have learned. First was strategic component selection matters. Choosing the right components maximizes impact within time constraints. Second, I tested each module before moving on to the next, so that is 100% pass rate. And third was adaptive processing balances, speed and accuracy was achieved. And fourth was showing confidence scores. Fifth was related to modular design, which enables the testability. And coming to the conclusion, ContextWeaver demonstrates academic excellence by exceeding the two component requirements, and like indeed had three components plus four innovations. It shows technical innovation through novel features like hybrid retrieval and uncertainty quantification that are not found in traditional RAG systems. It has production quality with 100% test pass rate and comprehensive error handling, and it has real world utility. It can handle any query, whether it's in the knowledge base or not. So looking ahead, like the main improvements would be like adding parallel API calls for 60% faster processing, integrating real web search APIs for better accuracy, and adding support for other models like Claude and Llama. The complete code and documentation can be seen over through this GitHub link, and you can reach me out on this email if you have any questions. Apart from this, I also hosted a web page which explains the project showcase, so you can see what is the project all about here, and what was exactly implemented, and the technical information, and also the stats. You can have access to the links, and there is a interactive demo as well. The video has been uploaded here, and you can see that you can directly test it over here, and you can see the results that are coming over here. This is a web page implementation, so it's not actually executing the Python code here. It is just mimicking the demo whatever I explained earlier. And here you can see the architecture that was explained earlier. So each and every architecture framework has been portrayed over here, and the key features have been portrayed over here, as well as the technical stack, and the core components have been mentioned. Along with that, the GitHub location related details are available over here, along with source code and all the other details that are essential. So project documentation and installation details are also provided. So this is hosted on Netlify app. So this concludes my presentation. Thank you for your time.